Number 1, determine the value of n in simplest form. So we have the equation I to the 13th plus I to the 18th plus I to the 31st plus n has to equal 0. Well, when we see powers of I, we want to do something with, we want to simplify them. We want to make them not I to the 13th, we want to make them more manageable. Well, when we deal with large powers of I, we need to remember that cyclic nature of I and how it repeats every 4. It has a cycle of 4. So I to the 13, we have to say, how many times do I rotate around the circle? How many times of 4 do I go around the circle? Well, if I divide 13 by 4, I have a remainder of 1. So that means it's I to the first. That means it's equal to I. I to the 13 is I. I to the 18? Well, when I divide 18 by 4, I have a remainder of 2. So that means it's I squared, because I went 4 times around the circle and ended up at I squared. I to the 31st. I to the 31st, well, how many times do I go around the circle? 31 divided by 4. Well, what's my remainder? That gives me a remainder of, well, 28, so a remainder of 3. I'm finding the remainder here. Plus I cubed plus n has to equal 0. Well, I is I. It's essential that you know that I squared is negative 1. That is the defining characteristic of I. So I minus 1. Well, I cubed is I squared times I, so that's negative 1 times I. So I cubed we need to know as negative I plus n equals 0. I minus I is 0, so negative 1 plus n must equal 0. Well, negative n plus what gives me 0? N has to equal 1. N has to equal 1 there. So using your powers of I, knowing that cyclic nature, knowing that you really need the exponent is really just the remainder. You need to know that the exponent is the remainder after you divide by 4. Number 2. Evaluate x squared minus 6x when x equals 3 minus I. So I'm plugging in 3 minus I. 3 minus I squared? Well, when I square something, I need to use a table. Or use the identity, but I think using a table here is simpler. 3 times 3 is 9, minus 3I, minus 3I. Negative I times negative I is I squared. But we know that I squared is negative 1. So we get 9 minus 1, which is 8, minus 6I. So 3 minus I squared is 8 minus 6I. And now we need to distribute in a negative 6 here. So minus 18 plus 6I. We end up, well, minus 6I plus 6I add to 0. 8 minus 18 is negative 10. So when I plug in a 3 minus I get negative 10. Express the following quantities in a plus bi form. 1 plus I minus 1 minus I, so let's distribute that negative 1 in. 1 plus I minus I plus I. 1 minus 1 is 0, so this quantity equals 2I. What's 1 plus I times 1 minus I? 1 plus I, 1 minus I. 1 times 1 is 1. I times 1 is I. 1 times negative I is negative I. I times negative I is negative I squared. And it's essential that you know that I squared is negative 1. When you square I is the number whose square is negative 1. So we get 1 minus I squared, I minus I, those add to 0. I minus negative 1 minus negative 1 is better known as 2. So this quantity equals 2, using that relation that I squared is negative 1. So negative I squared is positive 1. Part C, I times 2 minus I times 1 plus 2I. A couple ways to do this. I'm going to first multiply those binomials together. So make my table. 2 minus I, 1 plus 2I. 2, negative I, 4I, negative 2I squared. I squared is -1, so I like to think of I squared as a sign changer. It changes your sign. So I get 2 minus I plus 4I is plus 3I minus 2I squared. Well, I squared is -1, so this is really 2 plus 3I plus 2. So 4 plus 3I is the answer in A plus BI form of that product. Well, I need to take that product and multiply it by I. So after I distribute it in I get 4I plus 3I squared. I squared is -1, so that's 4I minus 3. But that's not in truly A plus BI form, because the real part is first and the imaginary part is second. So let's do -3 plus 4I. That's the final answer. Make sure you're actually writing your answers in A plus BI form. But does it truly make a difference? No, but you should be writing your answers in A plus BI form. 4. Express each of the following in A plus BI form. More complex number arithmetic. Can you add complex numbers together? That's important. Well, when we add complex numbers, we add the real parts, 20. We add the imaginary parts, 9i. Done. The sum of those two complex numbers is 20 plus 9i. When we subtract, we just distribute the -1 and get 2 plus 5i minus 4 minus 3i. Think about it as combining like terms. 2 minus 4 is -2. 5 minus 3 is plus 2i. And that's our final answer. So adding and subtracting is pretty straightforward. We just treat it as if we were combining like terms. 5. Express the following in A plus BI form. So I have a product plus 3i times another product. So let's take this part by part. Let's first find this product here. 1 minus I times 2 minus 3i. Well, that product, I'm going to use the distributive property here. I get 2 minus 3i minus 2i plus 3i squared. Let's simplify that. 3i squared, I know I squared is really -1, so that's really a -3. -3i minus 2i is -5i. So this gives me -1 minus 5i. -1 minus 5i is this first quantity. Use the distributive property over here, and I get 3i minus 3i squared. Well, I squared is -1, so this is really 3i plus 3, which in A plus BI form is that, 3 plus 3i. So I have -1 minus 5i, plus this quantity is 3 plus 3i. -1 plus 3 is 2, -5 plus 3 is minus 2i. That quantity apparently is equal to 2 minus 2i. So that's a great way to do it. But if you look for and make use of structure, you notice that 1 minus I is a factor of both terms. So if I factor that out all the way from the start, I'm left with 2 minus 3i from that term plus 3i. So I have 1 minus I times, well, 2 minus 3i plus 3i. Those add to 0. So this is really 2 times 1 minus I, 2 minus 2i. Looking for and making use of structure is an important thing to do because it makes the question a little bit easier as long as you're paying attention and making use of that structure. But did you have to recognize that? No, you could have done it all out by hand. Find the solutions to x squared minus 4x plus 13 equals 0 in A plus BI form. So when I'm solving a quadratic and I already know there's going to be complex solutions, I'm not even going to try to factor. I'm going to jump right to the quadratic formula. So I need to figure out what's my A, what's my B, and what's my C. Well, A is 1, B is -4, C is 13, and while we're at it, let's compute the discriminant. B squared minus 4AC is B squared is 16 minus 4 times 1 times 13. So this gives us a discriminant value of 16 minus 52. 16 minus 52 is 36. Negative 36. Negative 36 there. You could also just throw that right in your calculator from the start. So, using the quadratic formula, we know x equals negative b, so negative negative 4 is positive 4, plus or minus the square root of the discriminant, all over 2a. So x equals 4 plus or minus the square root of negative 36. Well, that's the square root of negative 1 times the square root of 36. And we define the square root of negative 1 to be I. So that quantity is 6i. Dividing every 1 by 2, distributing that division by 2, we get 2 plus or minus 3i. Those are the solutions to the quadratic equation there. I knew that I was going to have complex solutions because my discriminant was negative. So we can solve any quadratic equation now because we have these complex numbers. We don't need to panic when we see a negative under this radical because all we have to do is use that defining feature that the square root of negative 1 is I.